Hi, today I'd like to talk about test-driven development and how it can be applied in Rust. Test-driven development, also known as TDD, is a software development process that relies on the repetition of very short development cycle. Whatever you want to implement, first you would start implementing a unit test for that. Until there's no code to fulfill the test of course would fail. But you would still run it to ensure at least that it fails as it expected to fail, and not because of some other reasons like syntax errors or something else. Then you would implement a little piece of code in order to make the test pass. And probably you'd have to run and change code few times until you actually get the test green. When you have reliable tests that cover your functionality, you can spend some time to refactor what you wrote. Refactoring is a process of changing program's source code, keeping the same program's behavior, in order to make the code easier to understand and maintain. So this way tests give us a guarantee that we do not break a correct program's behavior and allow us to fiercely modify source code in order to improve it. So you would loop a little bit in this cycle, changing the code, running the test, changing the code again, and so on, until you actually get satisfied with how your code looks like. You may also refactor the test, but be careful. You don't want to introduce false positive tests, those that are green when your code are actually not working. You just cannot rely on such tests. So if you change the test, it's not a bad idea to try to break it on purpose to ensure that it still does its job properly. And then you would start the cycle again, implementing a new test that checks another aspect of your program. This is TDD in a nutshell. But there are a few points I want you to pay attention to. It's important to write a failing test first. This way you ensure that your test actually works and it affects the way you write your code. I often hear people say things like this: "This code is untestable." Well, dudes, I say it would be impossible to write untestable code if you write tests first. Another important thing to keep in mind is that test allows refactoring. And refactoring is the way to keep source code clean. Reliable tests and clean, understandable code allows you to quickly and safely adapt to constantly changing product requirements. In order to show you how TDD may work in life, I made up this artificial problem, and the problem is the following. Implement checkout that gets initialized with some price list and allows to scan items one by one and calculate total price. And here's an example of how price list may look like. So apple cost 40 cents, tomato 25 cents, and manga €1.80. And we are free to encode price list as we want. And that's an example if we scan 2 apples and 1 tomato, so we expect to get €1.05 in total. Before we start with the code, I want to cover some tools that can be very helpful when you write tests and do TDD. The first one is Pretty Assertions. It's a little crate that does amazing thing. Well, you can use just assert equal in your test, but it prints difference highlighted with colors, so it's just easier for your eyes to catch what goes wrong in your test. The next one is created by me. It's a Cargo plugin, Cargo Testify, and what it does, you run it and it watches your file. When your file is changed, it runs tests and shows you such nice desktop notification. So when test breaks, it shows red smile, and when it's okay, it shows this lovely angel smile like this. Yeah. And the next one is very similar. It's Cargo Watch. It it's similar to NodeMon in Node.js or Guard in Ruby. And so it does similar thing. It watches your files and allows you to run some custom command. Usually it's a cargo command, but you can also run shell commands. And I think it's very important to use it, so it just allows you to get feedback very quickly, and it really saves time, so you don't need to switch from your code to console, to type cargo test or something like this, see the test, go back to your code, change something in your code. It just happens automatically, so you always instantly getting this feedback from your tests. Now I'll start with installing CargoWatch plugin. So I type cargo install CargoWatch. It takes a while to fetch and compile everything. Here we are. So now we can check installation. Now I'll create a new project. I'll name it checkout. And it's gonna be library, so we don't need binary, it will be just a library. And yeah, what do we have? So we have this little default test, and I guess it's good time to show you how CargoWatch may work. Oops, I want vertical split. I type CargoWatch and X, and then what command I want to run when changes are detected. So it's gonna be tests. It's gonna be test. You see, it runs tests and everything's okay so far, but if I break test, it picks up automatically and runs test again, so it's broken. Let's say if I break syntax, again, it just gives us instant feedback. I find it very useful. Now I also want to add pretty assertions. So I go to cargo.toml and define some dev dependencies here. I needed to declare also in my lib file, so I copy this thing and yeah, basically it says use create pretty assertion, use macros from it, and apply it only for tests, so it will not be applied for program, for library, but only for tests, for modules that declared with this test. So let's see how it works. If I break the test again, cool, so now it's colored and looks a little bit better. Now we are ready, and let's implement something. I copied this price list here so we can see it, and let's start with tests. So I'll create test module, and let's implement the very first test. I'd like to create checkout structure without passing any prices because it's not implemented yet, and without scanning any items, just calling total, I would expect to get 0. So I create checkout, this will change, so we'll have to inject price list, but at the moment let's keep it as it is. And my assertion is calling checkout total to get 0. Has a typo. Ooh. And you see, this triggered automatically. And yeah, so we have to implement checkout now. It's gonna be a structure, and for now it's empty with little implementation. So first we need to implement new method that returns self, meaning returns checkout. And yeah, we have also to implement total method that is called on instance of checkout, so we need to pass self by reference, and it's gonna return float, and for now it's 0. So test pass. A little side note, it's never a good idea to use float to encode money. You probably would use something like decimal or measure money in cents and use integer, or use some special libraries to encode money, but float is never a good idea because of errors with precisions. Just keep in mind, we just do it for simplicity and never do it for real life applications. Okay, so looks like it works. Now let's say let's implement another test that checkout with 1 apple. And I copy initialization of checkout, then I would scan, and I don't know, but I need to define some apple here. It's not no yet. And my assertion would be calling checkout total to get price of 1 apple, which is 40 cents. And yeah, of course it's gonna break. There's some things are not defined yet. Scan method, then also apple. And let's implement items. Let's encode them as enums. And we have the following items: apple, tomato, and mango. Good. Now I'm gonna also use items in this code, so I'm gonna import all items. So instead of writing item apple, now I can just write apple, and it will be just alias to item apple. Okay, so it says that scan method does not exist, scan function doesn't exist. Let's implement it. Scan, it's gonna, so we actually need to save the fact that we scanned the item, and that means that actually scan is gonna mutate our state of checkout. That just means that we need to declare it with mutable reference. and item of type item that returns nothing. And now our first test complains, no, not first, but this test complains that actually we need to declare checkout as mutable. And now actually the program compiles but test fails. There are also some, I guess, warnings. Yeah, method is never used, and so this method is never used warnings. I'm gonna address them by declaring structure checkout and enum item as public, plus also these methods. So they're kind of part of external interface, so this means that we need to declare them as public so they can be exported to other modules and used there. Otherwise, Rust just detects that actually this never gonna be used in external world, and it's just that code. Okay, now let's try to fix it. Let's try to fix our test. So at this point we have to inject price list somehow, and first we actually have to define it somehow. So there could be like number of ways how we can define price list. We can use hash maps. Hash map, we can use, let's say, array of tuples. There are some edge cases when none of these are really good, like with hash map would meet the case when actually item may not exist if we did not set it, and with array of tuples like this. I keep the price. Okay, I did it. It looks okay, but actually nothing prevents us to have some duplicates in items with different prices, so this structure just doesn't looks correct. So I'm gonna enforce this with my own price list structure. Maybe not the best idea, but let's see how it works. So I'm gonna no yeah, let's start with test. We are following TDD. I'll just keep tests in the same namespace. Maybe again you would implement different namespace for different structure, but let's keep it simple for now. Test price list. And when it's default. So the idea, if I create price list structure and prices are not set, so all prices will be 0. Again, it's maybe not the best strategy. It's better to find some way to enforce that actually all prices are set explicitly. But let's keep it as it is for now. So I create price list. Yeah, maybe I renamed. No. I create price list like this, and I expect to have some get method, get function that I may call with the item like apple let's say, and it would return me, return me 0. And the same for other items. We have tomato and we have mango. So just because we did not set price explicitly, default behavior is 0, just to return 0. And yeah, I'm gonna run test again. Yeah, here's the typo. So now it says that price list does not exist. Let's define it. Again, it's going to be a structure. And we need to implement new and get functions on it. So for now, no, actually, it's going to be a structure and we need to define prices. Sorry, it has to keep prices for apple, tomato, and mango. And now we need to implement the functions. So at this point, I create price list structure with everything set to null, to 0. Now we have to implement get function. It's going to return float. And yeah, we need to pass item. And based on item, it would return different values. So we're gonna use match. If it's apple, we're gonna return self apple. If it's tomato, we're gonna return self tomato. If it's mango, we're gonna return self mango. Okay, at this point, at least we can compile, and what's important that this test already passes. I'm gonna just ignore this test for a while and focus on price list. The next test I'm gonna implement for price list is actually to test ability to set the prices. So price list set and get. Now here price list just it needs to be mutable, and I'd like to set prices like the following. So price of apple is 40 cents. Then price of tomato, it's 25 cents. And price of mango is €1.80. 80. Now I also have to define expectations, so after I set prices I must be able to read them and just to read the same values as I set. Now it complains about set function, so we haven't defined it yet. Let's define it, and again set gonna change state of price list. It needs to be mutable. Now we specify item and actual price for this item, and it doesn't return anything back. Now here's kind of duplication, so again we need to match items, and based on the item type we're gonna modify in particular field of the price list structure. If item is apple, we're gonna set apple price. If tomato, we're gonna set price for tomato, and for mango. Cool, so at least we have green tests. We have some kind of defined price list structure, even if it's not perfect one, at least it fulfills our tests. So we can go back to our checkout tests. Now I'm gonna modify this test to inject price list into checkout, and so I create price list, and now we need to adjust checkout new, and actually we have to tweak checkout function. So now we have to define price list field here. Here we define a price list that way that actually checkout owns price list. In real life application it may be better to define price list as reference to actual price list, but here in this example we just give all ownership of price list to checkout. And yeah, we need to set price list here. Yeah, another test complaints. Now it's this test just because it just cannot be compiled because signature does not pass. So I'm gonna comment it out. Okay, so it works as expected. Now let's fix this test. And I'm gonna inject price list. Okay, it compiles, but it still complains. I mean, test fails. This test fails because scan and total needs still need to be implemented properly. Now, what we're gonna do? So scan should somehow save the fact that item was scanned, and for that we would need some properties, some fields in checkout. So let's create items property. It's gonna be vector of items, and when we initialize our checkout, we set items just with empty vector, so it compiles, and now when we actually scan, we need to add this item to items. So I do items push item, and we need to adjust total. So to calculate total, we gonna iterate over items we have, and for every item we're gonna get its price and accumulate the prices. So we're gonna accumulate prices, let's say, in variable sum, which is at the beginning 0, then we iterate over items, items iter, and we gonna get price of this item from price list, and gonna add it to the sum, and we return total sum back. Yeah, okay, so we actually get a reference to item, but we want to get item. Okay, it complains about moving item, and we actually want to define, so items are quite simple enum, and in this example we don't want to care much about references, so we just can be copied because it will take just 1 byte, and it's the same as integers or some primitive types. So we just need to instruct Rust that actually we want to copy it when we pass to it somewhere. We will give ownership. I derive clone and copy traits. Just actually we need copy, but without copy it's just marker, and copy is not possible without clone. So it compiles, great. No, yeah, it compiles, but looks like total doesn't really work. Doch, it works. We just need to set up our price list properly here. So here I'll just copy prices from another test. And yeah, price have to be mutable. Works. Now, what next? Now I want to implement. Yeah, so probably. Yeah, I want to implement another test, more complex test that would just cover more complex case with multiple items. Again, I'd like to refactor slightly the test and to implement some helper methods that would build a price list and checkout. So build checkout, and I'd like to get back checkout, which I can test. So first it has to build a price list and then inject this price list into checkout and return checkout back. Now I can adjust this test to make it a little bit cleaner. And also this one. It needs to be mutable here. And now we can even improve it. So what really matters for us is just items that we scan, and so like apples, mangoes, tomatoes, and total price. That's what we want to test. So we can implement another helper method. Let's name it assort total, that would receive vector of items and expected total. And if it doesn't match, then we'll just panic with assort. So here we'll need checkout, the same checkout structure, and we'll iterate our items in our, oh, I forgot types, in our items, and we'd like to scan every item, and that get actual total and then assert that actual total matches our expected total. Yeah, so it can be compiled. Now let's replace this test with one line, assort total, and sorry, no, we pass empty vector and we expect to get 0. And let's break it just to ensure that it actually works. If I change some on purpose, so yeah, the test breaks. Now let's go back and change this test with one apple. And yeah. And finally, let's implement this more complicated test with multiple items. again, I'll use this assort total, and let's say I scan one apple, then one tomato, then one mango, then again one tomato, then again apple. And what do I expect here? So price of apple is 40 cents, right? 40, 25. And at this moment, when I scan first apple, total must be 40 cents. Then I scan tomato, and price of tomato is 25 cents, and total at this point is 65. I scan mango, which is €80, and at this point we get 2.45 of total. Correct. And I scan another tomato, which is 25 cents, and we get here 2.70. And finally one apple, and we get total of €3.10. That's what our expectation must be. And right here. So it works as expected. It means our test pass, and if I add another item on purpose just to break it, it breaks. So looks good. So at this moment, I guess we have more or less reliable tests that allows us to refactor something in our code. We can refactor, let's say, this total function. Instead of just iterating through items, we actually, instead of iterating with for in loop, we can make use of Rust iterators. It would be something like this, items, and we convert it to iterator, and now first step is to turn item into price. So I'll use map for this, and I get price from price list for every item, and then I would call sum to summarize this, to calculate sum of these prices. Now let's try to see how it works. Works just the same, so it's pretty good. And there's something that smells in this price list structure. So you see, and if it's not really dynamic, if we add a new item here, let's say orange, it means we need to add new field here, then change our new method, then change our get method and set method. So to add new fields, we would need to change code in 5 places in total, which is not great. And I'll keep it as it is. It could be, as I told, there could be different techniques to address the problem, using hash map, tuples, or encode prices with a static array here, and use some advanced metaprogramming technique first to to figure out how many items, how many variants in items, and then based on this define size of this static array in price list, and assign to every item here like some value that defines position in this static array in price list. So in real production, in real life application, you do it probably differently because it smells. And I saw there's some warnings. It says method set is never used on price list because we need to just declare them as public. It's also gonna be an interface of our such called library. So that's it. I hope you like it, and I really encourage you to try this approach next time you write your code. And if you don't feel confident, you probably I would recommend to find someone who familiar with this technique and try to pair program to learn it. It's really helpful. I really like it, and it just keeps me happy. So I'm really feel joy when I see my tests pass. Thank you for watching, and see you next time.